This page is 7 through 9 of the Polynomials packet for Unit 8. Let's look at this page of notes. Parts of a polynomial function. We have f of x equals q x to the d power plus all the way until we get our constant p. We said q x to the d is the leading term. Q is the leading coefficient. D is the degree. It's the largest exponent in the function. And then P is the constant coefficient. Factors of P over Q are all the possible rational zeros. If you look at this graph right here, we have the parts of a polynomial on a graph. So this first A1, is a root with a multiplicity of 1. That just basically means our factor would be x minus 1. A2, it says it's a root with a multiplicity of 2. So this would be x minus 2, but instead of it just be x minus 2, it's going to have it raised to the second power. And then A3 is a root with a multiplicity of 3. So this would be x plus 1 to the third power. Of course, this could be more than 2. It could be 4, 6, 8, even number. And then this number could be bigger than 3. It's an odd number that's 3 or more. So it could be 3, 5, 7, so on. Whenever it's asking for this, though, it's pretty much always have you assume it's the smallest possible degree. Now B is the vertices, it's the extrema. This B right here is a max. It's a local max. Also, it could be called relative. Relative local maximums are not the highest point, because arrows will be pointing above that. This one is a relative minimum. And so is this one. Well, actually this one is absolute minimum. It can also be called global. So it's the absolute minimum because there's no arrows that are pointing below this y value right here. C is the end behavior. The end behavior is what it's doing on the left side of the function and the right side of the function. So on this side, it is when x is approaching negative infinity, y is approaching positive infinity. And on the right side, as x approaches positive infinity, y approaches positive infinity. And then we have D for decreasing intervals. This is a decreasing interval. It's going, it has a negative slope. So anywhere that has a negative slope, that is a decreasing part of the interval. Increasing would be when it has a positive slope. We are talking about intervals. We're talking about the x values. The domain is broken up. It's broken up into two different types of intervals. Decreasing intervals and increasing intervals. Because domain's always going to be from positive infinity, negative infinity, or all real numbers here, so we might as well specify it a little bit more here. And then F is the y-intercept. 0, -4 in this case. And then, just like on almost all the other units from previous parts of this course, we have our transformation rules for functions. It's the same exact stuff as last time. Alright, let's look at practice 8E. 1 through 4 indicate whether each power function is a polynomial function. If so, write it in standard form, state its degree, type, and leading coefficient. So if we look at number 1, we have f of x equals negative 3x plus 5x cubed minus 6x squared plus 2. This is a polynomial function because all of the degrees are positive integers. The standard form, you just want to write these in order. So 5x to the third power minus 6x squared minus 3x plus 2. So your degree is 3, the type is cubic, and the leading coefficient is 5. Now let's look at number 3. h of x equals 9x to the fourth power plus 8x cubed minus 6x to the negative 2 power plus 2x. This is not a polynomial. Since negative 2 is not a positive integer. Now do numbers 2 and 4 yourself. Alright, let's look at 5 through 8. Describe the end behavior of each graph below by filling in the blanks. Let's look at number 7. g of x equals negative 2x to the fourth plus 12x to the seventh plus 17 plus 5x squared. Now the first thing we want to do is find the degree and the sign. The degree is the highest exponent, 7. And then the sign would be a positive because 12 is positive. So since the degree is 7, that's odd. And the sign, since the coefficient, the leading coefficient is 12, is positive. So as x approaches negative infinity, we can look at our table right here. We're looking for odd positive. That's this first one. So the graph will look something like that. So as x approaches negative infinity, f of x is going to be also going down. As x approaches positive infinity, the f of x is going to be going up. Try the other 3 questions on this page, and then go to the next page. Alright, page 9. 9 through 12. Describe the polynomial functions as having an even or odd degree, a positive or negative leading coefficient. So we see this one right here. Let's look at which picture it mostly resembles. It looks like the second one. That's odd and negative. Okay, do the other 3. See which picture matches those the best. Once you finish that, move on to the next section.